So hello, good evening everyone. So as usual, we will be having our weekly session today. Today is week 5, fifth session, and we'll have these sessions every week 7 to 8. My name is Akhil, and I'm currently a PhD student at IIT Madras. Okay, so this week we'll be dealing with failure theories. Yeah. So for question one, more given the combination sigma x, sigma y, and tau xy, now we are supposed to find the more draw the Mohr circle for the corresponding stress state and estimate the principal stress. Okay. Yeah. So can anyone tell me how can we get the so to draw the circle we need two main things, right? What are those two? Center and radius, right? So given the stress combination, how can we estimate the circle center and then the radius? So for this case, there is a direct formula. So the center would be the average of these two stresses, sigma x and sigma y. So sigma x plus sigma y by 2 would be the center, and then the radius would be sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay. So here we have sigma x as 50 MPa and sigma y as minus 10. So the center would be 50 minus 10 by 2. So 40 by 2 equal to 20 MPa. So the center is 20. So if you take this as the axis 1 and then this as the axis 2. So we have center as 20 and the radius is so sigma x minus sigma y. So 50 minus of minus 10 by 2 whole square plus tau xy square. Okay. So 50 plus 10, 60 by 2, 30 square plus 40 square. So this should be 50, right? Okay. So now we know the center and we know the radius. So this is the center and this is the radius. So this point would be center plus radius. So it would be 70.0 and this point would be center minus radius. Okay. So minus 30 comma 0. If you take this as the 0, 0. Okay. And then what would be this point? So this is the corresponding tau max. So it would be same as the radius, right? So it would be 0 comma 50. So is this clear to everyone? Given the stress combination, any stress combination, how do you draw the Mohr circle and then estimate the principal stresses? So in this case, what would be the principal stresses? No. It's not taken like that. You can take this could be minus 10 and this could be 50 also. Yeah. So usually sigma 1 you take as the positive maximum value. Yeah. So this I am saying sigma and this point is sigma 1 usually and this point is sigma 2. Okay, the principal stresses. So sigma 1 you take as the max value usually and sigma 2 minimum value. Right now here we got one positive and one negative, but both could be positive and both could be negative. Anything is possible. Okay. Yeah. So in this stress case, what would be the stress tensor in the principal case? So will it have any shear components? No, right? So Okay. Yeah. So in this case, so where tau is maximum, shear stress is maximum. So in that case, what would be the, so this is this case, and what about this case? So when shears are maximum, so in that case, what would be the stress tensor? So both sigma 1 and sigma 2 will be same, or sigma x and sigma y, both would be 20, and then tau would be 50. Okay. So see, this would be one case, right? So the case you have is 50 minus 10 40. So for that we got the center and radius, we do the Mohr circle. Now when we got the principal stresses, so that is a plane where the stresses, normal stresses would be maximum and shear would be 0. So in that case the stress components would be whatever values you got for the maximum stresses will be the x and y, and shear would be 0. Is that clear, Suresh? Yeah. So in the other case, perpendicular direction where you have shears are maximum, then it's not like the normal stresses would be 0. So whatever would be the center. Suresh, can you mute yourself? Yeah. So those stresses would be there, and then the shear stress. Okay. Yeah. So next question, we are given a stress state again now, but this is a three-dimensional stress state. Our job is to find the principal stresses and the maximum shear stress. Okay. So can anyone tell me how to do when it is three-dimensional? For two-dimensional, we have seen there is a direct formula to get the maximum values. So here with center and radius, you do the Mohr circle, right? So how did we get the principal components? This would be center plus radius, and this would be center minus radius. Okay. So this way, if you know the stress in 2D, you can easily estimate the principal components. But in 3D, how do you do that? So in 3D there is no direct formula. So let's say if sigma is any of the principal stress, then yeah, how can we get that sigma is so whatever stress components you have 40 10 40 40 40 10 minus that principal stress into identity matrix. So the depth of this should be 0. So if you do this actually, so this would be 90 det of 90 minus sigma 40 40 40 10 minus sigma 40 40 40 10 minus sigma. Okay, this should be 0. So if you actually solve this, what you would get is sigma cube minus invariant. So what I1 and I2, I3 are invariants. So I1 is the sum of the diagonal elements. So trace of this matrix A, if you take it as A. Okay. So this would be in this case 90 plus 10 plus 10. So 1 2. So I2 is second invariant. So that would be okay. So let me check the exact formula. Minus tau xy square. Yeah, minus tau xy square, tau yz square plus tau zx square. Okay, this would be the second invariant, and third invariant would be the determinant of A. So let's just write it as det of A. Okay. So if you do this, then you will get a cubic equation in sigmas. So here in this case, it would actually turn out to be sigma cube minus, we have seen I1 is 110 sigma square plus, in this case I2 here would be 2900 and determinant would be 39,000 minus 30,000, and this would be minus 2900. Okay, so minus I1 sigma square plus I2 sigma. I2 is minus 2900 sigma minus I3. I3 is minus 39,000 equal to 0. So this is sigma cube minus 110 sigma square minus 2900 sigma plus 39,000 is equal to 0. So if you solve this equation, then you will get three values for sigma. So those three would be the principal stresses. So is that clear? So usually cubic equations you might not be able to solve analytically, but in some cases you would be able to solve. So in those cases you need to find something which you can take common. So here so if I write this equation as sigma cube minus 100 sigma square, so minus 10 sigma square plus 1000 sigma minus 3900 sigma. So you can see I am writing this 110 sigma square as minus 100 sigma square minus 10 sigma square. This minus 2900 sigma is plus 1000 sigma minus 3900 sigma. So why this 3900? Because we have 39,000 here. Okay. Now here in these two you can take sigma square common. This would be sigma minus 100. So here minus 10 sigma you can take common. Okay. So then this would be sigma minus 100. Here take 3900 common. So this would be sigma minus. Let me check this one. Can you check? Can anyone check this invariant? Determinant ones. 39,000. So write this way. That would be useful in this case. So sigma minus 10 here minus 100 sigma will give you sigma minus 10 minus 3900 will give you sigma minus 10. Yeah. So this is manipulation. So this might happen in some cases it might not happen. So then sigma minus 10 into sigma square minus 100 sigma minus 3900 is equal to 0. Now you know one of the principles is 10. So if you solve this equation also you will get the other principles. Okay. So this is how you can get the principal stresses if you know the three-dimensional stress state also. Now let's look at the next question. So we are given a planar stress state and we need to find the factor of safety using normal stress theory and shear stress theory, and given yield strength is 140 MPa. So here also in usually failure theories you need to find the first principal stresses, then it would be easier to apply any of the methods. So here we are asking normal stress theory and shear stress theory. Okay. So first let's find out the principles. So sigma 1 would be sigma x plus sigma y by 2. Previously we have discussed center plus radius. So radius would be sigma x minus sigma y by 2 whole square plus tau xy whole square. Oh, so if you write 1 comma 2, so plus or minus. So this would be 40 plus 40 by 2, so 40 plus or minus root over sigma x minus sigma y is 0, so 0 square plus tau xy square is 30 square. So 40 plus or minus 30, this would become 70 comma 10. So is this clear? Principal stresses. Now we need to apply normal stress theory. So if it is normal stress theory, so the maximum stress which you are getting, the principal stress, should be less than the yield strength, right? In the normal stress directly. So here factor of safety, let's write it as f of s, is equal to sigma ys by sigma 1. So this is sigma 1. So 140 by 70. So 2. Okay. So if it is shear stress theory, maximum shear stress theory. So here we have sigma 1 and sigma 2. This is a plane stress. So what would be the other stress? Usually the stresses is a three-dimensional tensor, right? Three dimensions it will have. So the other would be 0 if you are taking a plane stress case. So to get the maximum shear stress, we need to factor of safety would be sigma, so tau yield strength by tau max. Okay. So tau yield strength would be sigma y by 2 by tau max. So in this case, what would be the maximum shear stress which we will get? So for that we need to see max of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, sigma 3 minus sigma 1 by 2. So whatever is the maximum, that will be the maximum shear stress. Okay. So here 70 and 10, 60 by 2. So 10 minus 0, 10 by 2. So 70 by 2. 35, 35. So the maximum is 35. So now what is sigma y by 2? 140 by 2 by tau max, which is 35. So 70 by 35. 2. So here in this case what you are getting is factor of safety from normal stress and shear stress. Both are same, if you have noticed. So in these cases where both are positive, then one of the maximum things would actually give you the shear stress. So in that case, we will have both factor of safety same. So even if it is negative, so in that case, yes, yes, Suresh, yes, 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 half of the sigma y by 2, yes, yeah. So here we have that 2, right, by 2. Okay, yeah. So even if both are negative, in that case also we would have maximum shear stress to be the same as one of the normal components, maximum normal components. Okay. So in that case we would have both factors of safety same. So is this clear till here? We will get into more complicated questions later on. So I hope this is clear to you. Yes. Yes. So we can't answer the exact questions in the assignments. If you are looking at the maximum shear stress theory, yeah. So you need to find the principal stresses, and from that you need to find the maximum shear stresses possible. Yes. Yeah. So which question exactly are you referring to? It's, yeah, yeah, exactly. Yeah, this one. So given stress state, you need to first find the principal stresses. Yes, we know. Yeah, first you need to find the maximum principal stresses, okay, and then find the maximum shear stress possible. Yeah. No, those are the normal stresses. You need to find the maximum shear stress. So this, the maximum value of this, one of these cases would be the maximum shear stress. So you need to find the tau max. So one of these values, the maximum in these three would be the maximum shear stress. Okay, one second. So in the previous case, we drew the Mohr circle, right? So what is the tau max you are getting? Is the radius, right? Tau max is the radius of Mohr circle. Now, if you know principal stresses, what is the Mohr circle radius? Sigma 1 minus sigma 2 by 2, right? So now in three-dimensional case, what we will have is three different Mohr circles would be there. So something of this sort. Then you would denote this as sigma 1, this as sigma 2, and this as sigma 3. So in this Mohr circle case, the tau max would be this point. So this would be sigma 1 minus sigma 3 by 2 in this case. But we don't know exactly what it would be. So in general, what you would take is the maximum of these three combinations. Sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, sigma 1 minus sigma 3 by 2. Whichever is the maximum in these three, that would be give you the tau max, maximum shear stress possible. Okay. Now this maximum shear stress should be less than or equal to the shear yield strength. Okay. Now if you write factor of safety in this case, that would be tau yield strength by tau max, and tau yield strength is tensile yield strength by 2, and tau max, let's say in this case, if you put sigma 1 minus sigma 3 by 2, okay. So this would be sigma 1 sy by sigma 1 minus sigma 3. So this is the case only when this happens, but usually you should look at maximum of these three, okay. Okay, Vinay? So in the case where if you are, yes, yeah, this is the down. The down is next question. In this case, only for this Mohr circle. But if you should take these three, you should actually compare these three values and then take, okay. Only for this case, this was valid. Because here if you see, the tau max would happen in the sigma 1 and sigma 3. Is that clear? Yeah. So for the above case, now we need to find the factor of safety using distortion energy theory. So what would be the distortion energy theory's effective stress? Can anyone tell me if you know the formula? This is it, right? So this should be less than or equal to yield strength. Then factor of safety would be Sy by root over sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. So here 140 by root over, our components are 70 and 10. So 70 square plus 10 square minus 70 into 10. So whatever this gives. So now you should be able to do, if it is a 2D stress case, you should be able to find the factor of safety using normal stress, shear stress and distortion energy theory. So is this clear to everyone? So yes. Effective or von Mises stress, anything you can do. So this is the stress which you need to compare with the yield strength in the distortion energy theory. Okay. Yeah. Let's move on to the next question. Now hydrostatic stress and debatoric stress for the system. So we have given two systems. Now we have to find the hydrostatic stress and the debatoric stress tensors. So can anyone tell me what is hydrostatic stress? Hmm? Yes, yes. So all sides stress is acting and it is equal. So the body is not distorting. Body is uniformly growing or compressing from all the sides without any distortion. Distortion implies shape change. So if it is maintaining a cube, cube is being still cube without any distortion on the sides or faces, then that kind of stress state is the hydrostatic stress. So if you are given any stress state, to find the hydrostatic stress, so let's take sigma h as the hydrostatic stress. So it's basically trace by 3. So here it would be 50 plus 60 plus 70 by 3. Okay. So what would be this value? 60, right? Now what would be the debatoric stress tensor? So let me write it this way. So the original stress tensor 50, 0, 0, 0, 60, 0, 0, 0, 70. That we can write now as 60, 0, 0, 0, 60, 0, 0, 0, 60 plus. So this is the hydrostatic stress system. So what would this be? So if you have to get 50, then 60 minus 10. So 60 only and 10. So this is the hydrostatic. Yes. So whenever any normal stress system is there, the hydrostatic component will be the case where all the stresses are equal and there is no shape change in the system. And then deviatoric would be the shape change, distortion component of the stress. Okay. So in distortion energy theory, we'll actually look only at the energy due to this distortion energy, and that is why you get that final equation. Now for the second case, so 10, 0, 0, 0, 20, 0, 0, 0, 30. So here what would be the hydrostatic stress? So it would be 20, right? So 30, 40, 50, 60. 60 by 3, 20. So the deviatory component would be minus 10, 0, 0, 0, 0, 0, 0, 0, 10. So this is sigma h, this is sigma d. So if you see, even though stress tensors are different, you actually got the deviatory component to be exactly same in these two cases. Okay. So the von Mises stress, whatever if you are writing, So yeah, let's calculate that von Mises stress. Let's see. So in the 3-dimensional, what would that be? The effective stress. Sigma 1 square plus sigma 2 square plus sigma 3 square minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3, right? So here we have 50, 60, 70. So 50 square plus 60 square plus 70 square minus 50 into 60 minus 60 into 70 minus 50 into 70. Okay, what would be this value? Can anyone tell me? Check and tell me. Let me. And if you look at the other case, 10, 20, 30. So 10 square plus 20 square plus 30 square minus 10 into 20 minus 20 into 30 minus 10 into 30. Okay. So if you have to find the same case but which is closer to failure, you need to compare the sigma is, and whichever will have higher will be closer to failure. So here I am not exactly sure if this will come same. So just check that once. If they are coming same, then both of them will be equally possible to fail. Okay. Let me just calculate these values. 50 square plus 60 square plus 70 square minus 50 into 60 minus 60 into 70 minus 50 into 70. So this would be 17.3. And then similarly, if you look at 10, 20, 30. So 17.3. So you see, even though stresses are actually different, in both these cases, the von Mises stress or the distortion effective stress is same. So both are equally possible to failure. That's because the deviatory components are same. Okay, is this clear? So because the effective stresses are same, both are equally possible to fail. There is no difference between these two systems with respect to failure. Now this question is again on invariance. So we have discussed earlier how to calculate the invariance. So similarly you can calculate the invariance. I1 which is the trace, I2 and I3 which is the determinant. Okay. So for this, that formula whichever used earlier will come. Okay. So let's move on to next question. Now tensile yield strength is 400 MPa. So given sigma Sy is 400 MPa. And shear yield strength according to distortion energy theory. So what here when they mean tensile yield strength and shear yield strength is, so in tensile yield strength they did a uniaxial tensile test. So when they did this test, it failed at some sigma ys. So that is this value. Okay. Now when they are doing pure shear, so and it fails, how is this tensile yield strength related to the shear yield strength? So that is the question. So in the pure shear, let's take tau. In this case, what would be the principal stresses? So sigma 1. So we know that it's pure shear case, center is, there are no axial stresses. So it would be 0. What would be the radius? 0 square plus tau square. So it would be tau. So principal stresses would be plus or minus tau. So in this case, what would be the von Mises stress? Tau square plus tau square plus tau square, right? So root 3 tau. So let's say this is corresponding to the failure. So this would be root. So minus into minus. So there is minus here. So now if you are using von Mises stress, so this should be less than or equal to, or in the failure case, this is equal to yield strength, right? So root 3 tau shear yield is tensile yield equal to. So now shear yield strength would be 1 by root 3 of tensile yield strength. Okay. So now yield strength is 400 MPa. So just plug in 400 by root 3. So is this clear? So yeah, next question. Stress is given as, so we have again given a stress thing, and we have given yield strength. So we need to find the factor of safety based on maximum shear stress theory. So how can we do here? Can anyone tell me like easiest way? If you look at the stress tensor, you can, because this is a three-dimensional. So you have to do that invariance analysis to get the actually principal components. But if you see, these values are 0. So this is actually, this system you can take as 2D and three-dimensional one more component. So in third dimension, the principal is already taken because the shears are 0 in that. So you need to find only the principals for this case. The other principal would be this. So let's take sigma 3 equal to 30. Let's write directly. Now for the other part, 10, 5, 5, 20. So sigma 1 would be 10 plus 20 by 2 plus or minus root over 10 minus 20 by 2 whole square plus 5 square. 10 plus 20, 30, 30 by 2 plus 15 plus 10 by 2, 5 square plus 5 square. So is this clear? So when you are given these complex questions, if it is taking time, so maybe you might not be given that complex questions. So look for these systems. Like if you can see similar ones, then you don't have to do that full with invariance, calculating the determinant and all. You can do simply like this. Okay. Now you know sigma 1, sigma 2, sigma 3. So using shear stress theory, what would it be? So again, you need to find the maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, sigma 1 minus sigma 3 by 2. Okay. So whatever is maximum, that you should consider for the tau max. So in this case, what would those be? Five into 3 plus root 2. So this is 22.07. 5 into 3 minus root 2, 7.93, and then 30. So what would be the maximum value in this? So 30 minus 7 would give you maximum. So this case. So 30 minus 7.93 by 2. Is that clear how I took that? So this is 11.04. Now tau max factor of safety would be Sy by 2 by tau max. So Sy is given as 50 MPa by 2, so it's 25 by 11.0. Okay. So whenever you are asked maximum shear stress theory, first you need to find the maximum of these three. So in this case we have all three values, but if it is a plane stress case, one of these would be 0. But still you need to consider all three and then take the maximum. Okay. Yeah. So let's move on to the next question. Yes. So we have a cylindrical rod and one force is acting on it vertically. There is an axial force P and then there is torque. So the values are given and the dia and length are also given. So we need to find the factor of safety in yielding and in fracture also. Assuming two different materials. So one material fails in ductile and other material has these properties and it fails in fracture. Okay. So can anyone tell me where should we start first? Okay. So let's look at this point, point A. So at that point, what would be the stresses due to all these three? So because of torque, there will be shear stress, tau. How would you calculate from the torque? Is torque into R by J, where J is pi d power 4 by 32. Okay. And torque is given, we know the radius. Now, what would be the axial stress at this case? So if you look at point A, and then see point C. So I am looking at the diameter at the central line, vertical central line. Okay. Now we have F, which will cause bending. So the system would bend something like this. So how will the bending load be? So here it would be tensile, and as you go down, the below part of the beam is compressing, so it would be compressive stress. Okay. So at A we have tensile load due to beam bending, and because of this P axial loading, so we have that also. So sigma at A would be due to beam bending. What is the formula? Beam bending moment into y by I, where I is pi d power 4 by 64, and y here would be radius, and then m bending moment at this point is force into length, right? So this plus the axial load P by A, where A is the area, is pi d square by 4. Okay. So now we have sigma x at point L. Let's take this axial direction of sigma x. So F L y is R by I plus P by A, and tau xy is torque into R by J. So is this clear? Now because we know sigma x and tau xy, so we can find the principal components, right? Sigma x by 2 plus or minus root over sigma x by, yeah. Yeah. So is this clear now? Like from torque, we have get the shear stress, and from the axial load and the beam bending moment we will get the axial load. Yeah. So now you will have the axial direction we are taking as x and the shear we are taking as xy. So at this point shear would be, you can take it as out of the paper, okay, something like this. So we have axial at point A and then the shear would be something like this, okay. Yeah. Now this would give you sigma 1 and sigma 2 would be, okay. So now if you are asked to use maximum or distortion energy theory, let's say if you are doing it with distortion energy theory, so should we just put the numbers directly? No? So force is 1 kilonewton, so 1000 into length is given as 300 mm, so 0.3, and radius is, dia is 20 mm, so radius is 0.02 by I, so pi into d power 4, 0.04 plus P by A, so P is 30 kilonewtons, so 30,000 by area, so pi d square by 4. And torque into R by G. So torque is given as 500 Newton meters, so 500 into radius is 0.02 by J, so pi into d power 4 by 32, okay. So can anyone calculate these values? So distortion energy theory, again you will calculate sigma E, which is sigma 1 square plus sigma 2 square minus sigma 1 sigma 2, and factor of safety would be yield strength by sigma. That's it. If you have to use maximum shear stress theory, so here you need to see sigma 1 sigma 2, so you need to find the maximum of, again sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, sigma 3 minus sigma 1 by 2, okay. So in the case where sigma 1 and sigma 2 are opposite sign, let's say sigma 1 is positive and sigma 2 is negative, in this case you can directly take 1 and 2, okay, because we will assume the other direction to be 0. So if they are of the opposite sign, their corresponding one would be the maximum, okay. So unless we calculate these values we won't know that, so without that you can only say the maximum of these three. Now this tau max corresponding factor of safety would be yield strength by 2 by tau max, okay. So is this clear? Distortion energy theory and maximum shear stress theory. So again we were asked to find the factor of safety during fracture also, given SUT and SUC. Okay, so for this there are actually three equations: Coulomb-Moore equation, Moore modified equation, and the final Moore modified effective stress. So we'll see the final Moore modified. So for that case you need to find actually some values called C1, which are, I will tell you now. So okay, these three values you need to find. So C2 would be sigma 2 minus sigma 3 plus 2 SUT minus SUC into sigma 2 plus sigma 3. So these formulas you would find in the textbook also. So the effective stress in this modified Moore equation is you need to find the maximum of C1, C2, C3, sigma 1, sigma 2, sigma 3. Okay. So you need to calculate each of these values and then get the maximum, and then the factor of safety would be SU2 by sigma max. So is this clear? Everyone? Suresh, is this clear? Okay. So that is it for this week. Hopefully, I'll upload this document and the video mostly tonight or tomorrow, so you'll be able to see. That's it for today's session. If you have any more doubts, we can discuss. Otherwise, you can leave. Thank you. Thank you.